Hi, hello. This is Takeshi Kurata from AICT Japan. Today, I'd like to talk about geospatial intelligence for health and productivity management in Japanese restaurants and other industries. In 2015, SDGs were adopted by the United Nations, and the same year, the Ministry of Economy, Trade and Industry, METI in short, and the Tokyo Stock Exchange started to select health and productivity management stocks in Japan. HPM required the simultaneous improvement of labor productivity and quality of working, QOW in short. As shown in this figure, QOW consists of health, workability, and rewarding, which is closely related to occupational safety and health, QWL, decent work, as well as social capital. To improve both labor productivity and QOW in a well-balanced manner, it is necessary to deal with a wide range of issues. Therefore, there are limitations in taking action by experience and intuition. And so, engineering approaches are essential. In this sense, it's natural to incorporate ideas such as digital twin and digital transformation, DX in short, as engineering approaches that contribute to HPM. Geospatial intelligence, GSI in short, is one of promising effective tool for this purpose. It supports problem solving by linking geospatial data, including positioning data, with other sources of data. By the way, spatial intelligence is often described as GeoInt, G-E-O-I-N-T. However, it has a little bit strong national security nuance, so here we call it GSI. Anyway, it has been reported that about 60 to 80% of data is related to location, and also that humans spend about 90% of their time indoors. In light of those facts, we believe that GSI, especially indoor GSI, is an effective way to promote DX. Well, this left figure is the conceptual diagram of GSI. GSI makes organic use of both, number one, digital twin, IoT, IoH technologies and methodologies, and number two, social technologies and methodologies cultivated in service engineering, IE, and so on, so as to provide a comprehensive understanding of the current situation in service and manufacturing sites while acquiring 6M data. Here shows what 6M data is. 6M data consists of man, machine, material, mother nature, money, and method. And then, in addition to comprehensive presentation of the current situation, GSI can support process modeling, Kaizen improvement support, and also preliminary evaluation by simulation. I will now show you tables 1 and 2, which are a little bit too detailed though. They aggregate the use cases of GSI in service and manufacturing sites. First, this table, table 1, lists purpose, objectives, method, effects and results, positioning technologies used, and joint research partners or investigation sites. The sites and job categories include helpers and nurses at nursing homes, guest room attendants at Japanese inns, customer service assistants and catering staff at Japanese restaurants, and flight attendants on passenger planes. Moreover, office workers, building maintenance workers, pickers at distribution warehouses, and manufacturing workers at cable factories are also included in this table 1, in our use cases. Each row of this another table, table 2, present the evaluation items, indicators, and contents related to labor productivity and QOW for each case in the same row of table 1. As shown in this table, both of productivity and QOW have been addressed in most of cases. We have studied applied GSI with a clear awareness of QOW and HPM only since 2015. However, actually, we confirmed that both productivity and QOW had been already targeted since 2010, when we studied applied GSI for Kaizen improvement. Over the years, especially through practical experiments in Japanese restaurants, GSI-related technologies and methodologies have been developed and improved, and knowledge has been accumulated. In addition, in the past few years, we have confirmed that the technologies, methodologies, and knowledge can be transferred from the service side to the manufacturing sites. As an example of GSI utilization, we briefly present a case study of a Japanese restaurant in 2012, along with each item in tables 1 and 2. The purpose of using GSI, in this case, was to reduce the physical workload of the employees while maintaining hospitality, which had been already improved in the previous year. In order to achieve this goal, a computer-supported quality control circle activity, CSQCC activity in short, was conducted by measuring flow lines, analyzing descriptive statistics of each indicator, and visualizing them. For measuring flow lines, the CSQCC installed an integrated indoor positioning system based on pedestrian reckoning (PDR), active RFID, and map matching. In this case, the participants proposed spontaneously the adoption of an area in charge system, and it resulted in a short walking distance while maintaining hospitality. In addition, as a spin-off effect of adopting the area in charge system, skill indicators for individuals and teams were designed, as in the dedication and defense ratios regarding the area in charge. These indicators were derived from post point of sales data, and it allowed us to visualize the distribution of the skills of each wait staff. As a result, in this case study, it can be seen that GSI is capable of efficiently and simultaneously treating productivity, health, rewarding, and workability, which are wasted flow line, physical workload, hospitality skills, spontaneity, information sharing, and transparency of work conditions, respectively. The purposes of each case have been naturally progressing from as-is comprehension alone to supporting Kaizen improvement and pre-assessing to-be hypotheses by simulations. In addition, their specific objectives have become broader, such as workload labeling, skill analysis, training support, support for new restaurant launch, reduction of physical mental load, support of safety and health management, verification regarding work restructuring, robot installation, communication exercise space installation, support of low vision and blind workers. In some cases, existing indicators can be applied, while in other cases, the use case process starts with designing indicators. The evaluation items for labor productivity include: number 1, evaluation items that can be applied directly from geospatial data, such as wasted movement, traffic congestion, and deviation from standard operation. Number 2, evaluation items that can be applied indirectly from geospatial data, such as workload and working hours. And number 3, other items, such as number of additional orders, service quality, added value, and labor productivity are used. As I told you before, QOW consists of health, workability, and rewarding. As for health, The walking distance is used for both the negative and positive or health-promoting aspect, which are physical workload and exercise intensity, respectively. Geospatial data is also applied to the evaluation of exercise space usage rate, such as duration of stay in the area, and mental load, such as relaxation or contingency allowance. Speaking of rewarding, as I introduced, individual and team skills are evaluated based on flow lines, movement speed, duration of stay, and working hour, or the dedication and defense ratio in charge. For qualitative evaluation of skills by retrospective interviews, should first-person view videos generated with 3D models of work sites and flow lines are sometimes used as visual geospatial contents. And with respect to interpersonal relations and organization out of workability, it's confirmed whether information sharing, transparency of work conditions, and visualization of the 6M data have been carried out. And geospatial data such as flow lines and heat maps are used as contents for this purpose. Other evaluation items for interpersonal relations and organization include fairness, descriptive statistics of communication, and employee satisfaction. Flow lines and heat maps are also utilized to validate the safety when working alone, and the intersection situation between workers and vehicles. There's also a diversity-related case in which the feasibility of work support of low vision and blind people is evaluated with working hours. In this talk, a wide range of actual cases are summarized to contribute to the study of how to utilize GSI to promote DX for the purpose of HPM. The summary demonstrates that there are diverse but common indicators obtained directly or indirectly from geospatial data, and that they can be easily applicable by GSI. By dealing with multiple items related to labor productivity and QOW at the same time, the organizations will be able to maintain a high balance between them. In addition, the organizations also receive the advantage of being able to disperse the initial and running cost of GSI over several purposes, rather than just for a single purpose. DX means digitizing 6M information, including geospatial information, and transforming product, services, business processes, and ultimately the organization. However, it takes a long time to see results after digitization, and not a few organizations find it difficult to gain understanding of GSI implementation from both the executive and labor sides. The only way to achieve this drastically is to spread the concept of DX throughout society. But making it easier to introduce, operate, and maintain the GSI infrastructure, and improving interoperability in groups such as supply chains using 6M data will also contribute to promoting the application of GSI at the practical level. In addition, geospatial artificial intelligence, GeoAI, based on machine learning, are likely to attract more and more attention from service and manufacturing industries from now on. So we will continue our research and development on how GeoAI can combine the evaluation indicators summarized in the study and utilize them for the variety of purposes, or whether GeoAI can acquire new metrics or not. That's all. Thank you for your attention.